हेलो दोस्तों, कैसे हो? मेरे इस YouTube चैनल में आपका स्वागत है। तो चलिए शुरू करते हैं। General procedure in machine design. Now this is very important because when you will design your project, if you will do a manufacturing type of project, then this steps will be applicable. One, two, three, four, five, six. How many chairs I have shown you? One, two, three, four, five, six. If you want to design any of this chair, the procedure remains the same. But for designing this chair, or for designing this chair, or for designing this chair, all are wooden chair. Will the value of stresses be same? See the height of this chair from here to here. Height is less. See the height. Now height is more. It means that the force acting on this is also more. Force acting on this is more. Here the force acting can see from the design of the chair is less. This is another design of the chair. So we can have different designs. All these are different designs. Okay. Some this is for this is a foldable chair where you can keep something and write on it. This is the resting chair and all those things. Whenever we have to design all this, the basic procedure remains the same. What is the basic procedure? The first is need or M. Why are we designing a chair? Are we designing a chair for to be used it in a classroom? Are we designing a chair for an old person to rest on it? Are we designing a chair for some auditorium or hall um, here like this or like this? Or are we designing it for a maybe a kid, 8 to 10 years or 6 years, 4 years, whatever it is? What is the need or M? So this is the first question that should be asked. What is the need for designing the product? Similarly, if it is a fan, if it is a fan, then this is one blade, a second blade, third blade. Why are we designing a fan? Are we designing a fan for the what should be the sweep of the fan? What should be the sweep of the fan? Okay, how much area it should cover? So based on that, we have to use the different mechanisms in the product with different material and all those things. Okay. So the first thing is you have to identify what is the need or M. Second is what are the various mechanisms that will be used. Mechanisms can be sometimes we can use, not in this case, we can use chain drive, we can use belt drive, we can use gear drive, we can use sprocket mechanism, chain and sprocket mechanism. It's similar to this. Sometimes we can use rope mechanism. So which mechanism will be fit in the product that we are going to design? So it depends on what? It depends on what is the need of the product. When will we use gear mechanism? We will use gear mechanism when we don't want any type of error or as compared to the belt or gear. Here we don't want error. Here a little amount of error is acceptable. Okay, so depending on where error is accepted and where it is not accepted, it depends on the product. So which product I am designing? Okay, I am designing X product. For X product, whether I should use a belt mechanism or I should use a chain mechanism or a gear mechanism. Should it be a pneumatic drive or should it be a hydraulic drive? How it will decide? If the precision required is more, then hydraulic drive. If precision required is less, then pneumatic drive. If the amount of load to be lifted is more, hydraulic drive. If amount of load to be required lifted is less, then pneumatic drive. So this is again a mechanism. So depending on for which part are we doing, we will select the mechanism. Once we select the mechanism, we will do the analysis of forces. What are the forces acting on it? For example, this chair. What are the forces acting on this? The chair force because of the weight of the person. Now, where the force will act? The force will act on this seat, plus it will act this on this arm. It will act on this arm, and this is the rest chair. So force will act on this also. Force will act on this legs also because it will roll, rock and roll type chair. So what are the forces acting on it? Once we decide the forces, suppose we have identified that the forces acting on this are this much and maximum force maximum force is say 50 kilonewton. Maximum force acting is 50 kilonewton. Suppose we have arrived at some number after doing analysis of forces. Where have we studied this? We have studied it in mechanics, analysis of forces. So we come to know that 50 kilonewton is the force acting now. Now based on this force, which material should we select? Why material is important? Because what is stress? Stress is dependent on the material. If we select say 20 C8, 20 sorry 20 C8 as the material, then the stress will be some 200 Newton per mm square. Which is the stress? The tensile strength. Tensile strength of the material is suppose 200 Newton per mm square. If we select 40 C8, then maybe tensile strength is 220 Newton per mm square. Now, if you want a material which will bear more stress, then we'll select this. If you want a material which will bear less stress, then we'll select this. So based on the requirement, we will select the stress. So for stress, we need to select the material accordingly. So once we know what is the force acting on, we'll select the material. Once we select the material, we'll find the uh, we'll find the stress means we know the stress from the design data book. What is the stress for a particular material? And then what will we do? We will design the element. Now again see here, P is equal to pi by 4 t square into sigma t. I'm talking about design of element. This thing. P has come from here. Sigma t is what? Sigma t is the stress. Stress has come from here. How the stress is decided? For different material, the values of stresses are known to us. And now we have designed, and what we got here? We got the diameter now. What is the diameter? Diameter is D. We can find by knowing the value of this load and the value of sigma t. This is the next step, that is to design the element. So before designing, so many things are to be done. But in our case, what we'll study in this subject is we'll start with this analysis of force. Not even analysis, we'll be knowing the value of force. We'll be knowing the value of force. Once we know the value of force, we'll find the material, we'll find the value of stress from the design data book, and we'll do the design. This is the design. This is the design. Then that design will be modified. If we need to modify the design, if we need to change the dimensions, then we'll do the changes in dimensions. And then after the modification is done, then we'll make the detailed drawing, and then that will go for the to the production department for production of the part. So this is the general procedure that has to be followed for designing a product. First is to determine the need or aim why a product is to be designed. Second is the mechanisms, the set of mechanisms that will be used in it. Third is to determine the maximum force that will act on it. Then based on the force, we will select the material, and then the stress stress for the particular material will be known. After we know the value of stress, we will design the material. After designing the material, it will go to the department, manufacturing department. They will suggest some changes. If there are changes, then the design will be modified. If there are no changes, then the same design will be used to prepare the drawing, the two-dimensional drawing of the component, and then it will go to the production department for production.